In order to troubleshoot a problem on a machine tool, it is important to know where to start. This video provides a description of the areas of responsibility for the CNC and the ladder logic. This will tell you if you are dealing with a Fanuc problem or a machine tool builder issue. We will also look at the addressing scheme used in the ladder. Fanuc sells you a motion control device. It is up to you to integrate this device into the machine. This integration is done through the Programmable Machine Control, or PMC. Most of the world calls this a PLC, Programmable Logic Controller. They are basically the same thing. Think of the CNC control as two separate devices, the CNC side and the PMC side. They are in fact one computer, but when it comes to troubleshooting, you will find that it is much easier to think of them as two separate items. The PMC and the CNC each have areas of responsibility. The CNC has the responsibility for motion control. It is in charge of the motors, servos, and feedback devices. The CNC is also responsible for executing the part program. It reads each line in the program, executes each command, and verifies that this command has been completed successfully. Once each command has been completed, it will clear the end of block signal, jump to the next line, and execute that line. When the CNC executes a part program, it has one simple goal: clear the end of block. In order to do this, it must get verification that what it has asked to happen has in fact happened. If it tells the axis to move, it wants to see, through the feedback device, that the move has completed. If it tells the tool changer to pick up a new tool, it wants to get verification back that the tool changer has done what it was told to do. This will come in the form of a finish signal. This brings us to the third area of responsibility for the CNC: the interface to the PMC. The CNC and the PMC are always talking to each other. The CNC tells the PMC what its status is, and the PMC tells the CNC what is going on in its world. A large part of diagnosing machine tool problems lies with understanding this interface. The last area of responsibility for the CNC are the auxiliary functions. These include items such as CNC alarm codes, the display unit, diagnostics, and the MDI keypad interface. The PMC also has four areas of responsibility. The first responsibility is ladder execution. It reads and executes the ladder logic commands that are created by the machine tool builder. The second area is the machine tool builder interface. The PMC talks to the machine through inputs and outputs. I call these real-world devices because you can put a meter on a wire someplace and measure the actual signal. The third area of responsibility for the PMC is the CNC interface. Remember, the CNC and the PMC are always talking to each other. This is how the CNC finds out what is going on in the real world, and the PMC sees what the CNC wants to see happen. The last area of responsibility for the PMC are the machine tool builder alarms. These alarms will typically start with a 1000 or 2000 number. The CNC, who is in charge of motion, generates alarms relating to its areas of responsibility. The PMC generates alarms related to the machine tool builder side. These will include items such as door not closed, spindle not clamped, or overload tripped. Let's talk about the addresses used in the PMC. There are a number of address types. Each has a specific function. The letter X is used to designate a real-world input. Remember, it's called real-world because somewhere you can find a wire connected to it and measure this signal with a meter. The machine tool builder is responsible for wiring up all X-value inputs. These can be items such as push buttons, rotary switches, pressure switches, or contacts. Since the X addresses are inputs, they can only be used as contacts in the ladder. You will not find them used as coils. If you are familiar with the Allen-Bradley control, they refer to these as I signals. The letter Y is used to designate a real-world output. Once again, the machine tool builder is responsible for connecting all of the Y value outputs. An example of these are LEDs, relays, solenoid valves, or motor starters. The Y addresses can be used as contacts or coils in the ladder. Allen Bradley refers to these as O signals. All addresses after this are imaginary. You cannot use a meter to read any of them. They can be viewed in the diagnostics pages or ladder only. The letter G refers to signals that go from the PMC to the CNC. Think of it as G goes to CNC. G addresses, like the Y addresses, can be used as contacts or coils in a ladder. An example of this is a cycle start signal address, G7.2. When this signal goes high, the CNC, who is responsible for program execution, will start running the program. Now wait a minute. The cycle start button does that, right? No. The cycle start button is a real-world device. It has a wire connected to it that runs to an input card. The PMC reads this input as an X address. Somewhere in the ladder, there is a rung that takes this X address and uses it to turn on a coil, G7.2. The CNC responds to the G addresses, not the X. The letter F refers to signals coming from the Fanuc to the PMC. Think of it as F from the Fanuc. A good example of how the PMC uses this address would be a brake release on a gravity-supported axis. It would be a very good idea to know that the servos are online before releasing a brake. The CNC is responsible for the servos. When the servo drives are enabled, the CNC will send a message to the PMC telling it that it is happy. This address is F0.6 on most controls. F0.6 would be a contact on a rung in the ladder. When this bit goes high, a Y value output will be turned on. This will send out a signal to release the brake. If for any reason the CNC turns the servos off, F0.6 will go low and the brake will clamp. F addresses, like the X addresses, can only be used as an input. Fanuc assigns all G and F addresses. So here is a scenario for you. You walk up to a machine and attempt to jog the axis using a jog button, but nothing happens. Where do you start looking for the problem? It's very simple. Remember to ask this question: was it towed to? This is a very important question. Was it towed to? Pushing that button activates an X address. The CNC, who is responsible for motion, only responds to G addresses. In this case, address G100.0 tells the CNC to jog the axis. Go into the ladder. Look up address G100.0. Look to see if it is going high. If it is not, the axis was never told to move. The CNC is doing what it thinks it's supposed to be doing, holding still. The secret to troubleshooting a lot of machine tool problems lies with understanding the F and G addresses. Once you understand how they work, the amount of time it takes to solve a large number of machine problems can be cut in half. There are other addresses used in the ladder logic. The one you'll see most often is the R address. It is used as a register in the ladder. Basically, they serve as temporary coils and contacts used in the ladder for decision-making purposes. They do not have a real-world input or output capability. In other words, don't look to hook up a connection to them. The R addresses are free and there are thousands of them. You use these to keep track of what is going on in the ladder. When you look at a ladder diagram, you will find that the vast majority of addresses are R's. Allen Bradley uses the B address for this function. There are a few of the R addresses that Fanuc has grabbed for specific operations in the ladder. These are usually in the R9000 range. We discuss these in the Advanced Ladder Logic course. The C address is used in the ladder logic as part of a function statement. Function statements are macros developed by Fanuc to simplify the programming. This particular address is a counter. When the counter is incremented by a set number of times, it will turn on an output. The T address is used as a timer. There are several types of timers used in a Fanuc ladder. A timer will begin to count up when it is activated. Once it has reached a set value, it will turn on an output. If the timer is deactivated for any reason, it will begin counting from 0 when it starts up again. All timers in a Fanuc PMC are count-up timers. K addresses are keep relays. They serve several functions. One is to turn on or off various settings in the PMC control. These settings relate to items such as how the PMC starts up, the display of certain screens related to inputting and outputting information about the PMC, and certain diagnostic functions. A keep relay is set by going to a keep relay data table. The information is stored as a binary pattern. Once the keep relay is set, the control will remember its last state, a 1 or a 0. When the power to the machine is turned off and back on again, the PMC will look at the keep relay table and set the appropriate contacts high or low. The keep relays can also be used to enable or disable certain functions in a ladder logic, such as automatic doors, index tables, or robot interface. Typically, a machine tool builder will write one ladder for a machine model. Not all machines are sold with all options. The machine tool builder will use the keep relays to enable the options that a customer purchased. Keep relays can be used as contacts or coils in the ladder. Some builders use them to retain the status of certain events. Since the last state of the keep relay is retained in memory, it can be used to record information such as what pallet was in the machine when it was shut down, or the clamp-unclamp status of a chuck. Unfortunately, there are a limited number of keep relays in a machine. In addition, the information could only be entered in a binary format. Now the machine tool builder started to complain about this. Fanuc came up with a solution: the data register. These will show up as D addresses. There are a large number of data registers available to you. Like the keep relays, the last known status is remembered by the machine when the power is cycled. Now you have the ability to keep track of a large number of items, such as what tool number is in each tool pot, and to make things easier, Fanuc allowed the machine tool builder to enter the data as binary or decimal. This made it much easier for the average person to look at the information and make adjustments as needed. Like the keep relays, the data registers can be used as contacts or coils in a ladder. Both the data registers and keep relays can be set from within the ladder logic by activating a coil. The machine builder can create multiple data tables to store different types of information. The last address I will discuss is the alarm signal, the A address. Remember that the Fanuc control is a motion control device. It is in charge of the servos and motors. It is not in charge of items such as tool changers, doors, or chip conveyors. These items are the responsibility of the PMC. If something goes wrong with one of these items, the machine tool builder wants to stop the operation and display an alarm message. To display a message, he will set an A address high. Each A address is assigned a message by the machine builder. The machine builder can assign a number to the alarm. Alarms in the 1000 range will stop the machine operation. Alarms in the 2000 range will allow the machine to continue running. This is a brief description of the PMC to CNC interface. For additional training on Fanuc ladder logic, diagnostics, and the hundreds of F and G addresses available, contact Automation Consultants.